Alright, so at the end of class today, we talked about the equation of a line and everything you remembered about slope and graphing lines and y-intercepts and all that stuff. And I have Mr. Lang sitting next to me here, and he said you went over all of this last year, so you should remember a lot of this. So what we're going to focus on today in our formula, our y equals mx plus b, is the m. And as we talked about, the m stands for slope, or it's the symbol for slope. And we decided we could call that rise over run, change in y over change in x. And at the very end, we came up with our new formula. Well, not our new formula, but our old formula, which is right there. So slope m equals rise over run, change in y over change in x, or with symbols, y2 minus y1 over x2 minus x1. And when I ask you to find the slope between 2 points, you can kind of take your pick. If you want to get out a piece of graph paper and graph those points and then count your rise over run like we did in that example in class, you can do that. So you could count your rise over your run. Or what probably makes a little more sense, since we don't have this graphed already, we can just use the formula. So like we did at the beginning of the year with our distance and midpoint formulas, you can label those x1, y1 and x2, y2. And just really carefully plug it into our formula. So we have y2 minus y1 over x2 minus x1. So really carefully just taking these points, plugging it into our formula. 2 minus 6, careful with your signs, is negative 4. 1 minus 2 is negative 1. Negative 4 divided by negative 1 is a positive 4. So there's the slope of the line between those 2 points. And you hopefully would have gotten the same thing if you put it on a piece of graph paper. Okay, so that's one of your online homework checks, is just working with the slope formula. Now I want you to do this on your own. So this is exactly what we did in class today. We graphed the line and we found the slope. So we counted the rise over run. So what I want you to do is find the slope of line A, find the slope of line B, and then write what you notice about those slopes. So I'll pause, you guys can do that, and then when I unpause, we'll compare our answers. So go ahead and do that now. So what you hopefully notice about these parallel lines is when you count the rise over the run, and you can see I picked some points that were right on the corner of those grid lines. So when you counted the rise over the run, up 1 over 2, up 1 over 2, and same thing for line B, up 1 over 2, up 1 over 2, those lines are increasing at the same rate. So they're both increasing at that same rise over run of 1 over 2, so they will never cross. They're both rising at the same rate of change, the same slope. So you should have gotten those for your answers. 1 over 2, rise over run, there's your slope. And what do you notice? They're the same. So that's a very important observation. Parallel lines have the same slope. So now to write the equation for these lines. This is a little bit of a preview for what we're going to do next class, but we can do this now. Y equals mx plus b is our formula. So we know m is the slope. So we know both of these lines are going to have a 1/2 for the m. And now the only thing we have to plug in is the b value, which is the y-intercept. So the y-intercept for line A is right there at positive 1. The y-intercept for line B is right there at negative 3. Remember, the y-intercept is where the x-coordinate is 0, and basically where the graph crosses the y-axis. So there's our y-intercepts. So in our formula, the first line A is y equals 1/2 x plus 1, our y-intercept. And line B, the y-intercept is negative 3. So there's the equation of those lines. Okay, so we'll flip. let's fill this in. From this exercise, we can state that the slopes of parallel lines are the same. The slopes of parallel lines are the same. Alright, so looking at a couple quick examples, remember the whole thing that we have to do first, before we start looking at the slopes, is we have to get y by itself. So for example A, we can see the y variable is already by itself, it's already isolated. The slope of both of those lines is 3. Alright, notice it's not 3x. The slope is not 3x, it's just 3. Alright, for example B, sometimes you will have to reduce, so we always want to keep those slopes as fractions to make the reducing easier. But 3 over 6, we know, can reduce to a 1 over 2. Same slope. Alright, letters C and D, there's a little bit of work to do. We're not going to do this now, but you have to do a little bit of algebra in order to get them in y equals mx plus b form. So you always want to get the y by itself. Okay, so parallel lines have the same slope, and we'll identify that slope once we get the y equals mx plus b form set up. Alright, scrolling down, perpendicular lines. So we know, remember, perpendicular lines, there's our symbol. We know perpendicular lines form a 90-degree angle. So I want you to do the same thing. I want you to find the slope of these two lines on your own. So this, I think, is something new for you. So I'm going to pause again. I want you to count the rise over the run and see if you can figure out a pattern here for these perpendicular lines. So go ahead and do that now. All right, so check your work. Hopefully you got, for the slope of line A, negative 1 over 3. And for the slope of line B, 3 over 1, which reduces down to 3. Now here's the thing for perpendicular lines. What do you notice about the slopes? One is negative 1 over 3. The other one is positive 3 over 1. So the slopes of perpendicular lines are what we call negative reciprocals. Negative reciprocals. So they are opposite signs and flipped. So that's what that word reciprocal means. They're the fraction just flipped the other way. All right, so we're not going to write the equation of these. We'll get back to that a lot more later. But that's how you identify perpendicular lines. They are negative reciprocals. So we'll flip to the next page and take that note. So from this exercise, we can state that the slopes of perpendicular lines are negative reciprocals. All right, negative reciprocals. So a few examples. Same deal. We got y by itself for this first example. This is actually the same one we just looked at. The slope of that line is 3. The slope of that line is negative 1/3, so it's flipped upside down and the opposite sign. Those are perpendicular lines. Same thing here. 3 over 5, negative 5 over 3. Okay? And then for C and D, kind of similar to before you look at the slope, remember the slope of this line isn't just 4, right? The reason why that slope's not just 4 is because we haven't gotten it into y equals mx plus b form yet. You always, always, always have to get it into y equals mx plus b form first. Okay, so we'll do one of those later where we have to do a little bit of algebra, but I want to finish this up. Parallel lines, there's our symbol. Parallel lines, same slope. Perpendicular lines, there's our symbol. Perpendicular lines have slopes that are negative reciprocals. All right, so that's to kind of summarize our lesson. Now to finish up, I know we looked at this in class a little bit. Slope-intercept form. For the equation of a line, that's our y equals mx plus b. All right, slope-intercept form, that probably looks really familiar to you. M is the slope. B is the y-intercept. And again, the y-intercept is where the graph crosses the y-axis. All right. I'm going to go through this real quick. A positive slope. The graph is going uphill. Positive slope. Negative slope. Going downhill from left to right. Okay? A zero slope. We're probably very familiar with this from last unit, but zero slope, y equals 2 would look like that. Horizontal line. And an undefined slope, boom, right there. Vertical line, and that's where x equals 2 would be. All right, so as always, guys, if I went too quick there, pause, rewind, use your strategies that we've been doing all year. Make sure you have all this down. And we'll do one example, I think, and then we'll call it a video. We'll call it done. All right, so we're going to try number 6. So if you want to try it on your own, you can pause and check your work in a minute. I will kind of walk you through this one. So we're going to look for a slope of the line perpendicular to this line here. So the first thing we have to realize is that the slope of this line is not 4. All right, even though the 4 is in front of the x right now, we have to first get this equation into slope-intercept form. We have to get the y by itself. So I'm going to bring this back over here and rewrite it. 6 equals 4x minus 2y. Now we just have to do a little bit of algebra. You can try this on your own if you want, but we need to get the y all by itself. So what I'm going to do is I'm going to add this 2y to this side, and I'm going to subtract the 6 to the other side. So I'll kind of do it all in one step. So the 6 minus 6, those go away. I'm left with 2y. Over here, the negative 2y and the plus 2y, those go away, and we're left with 4x minus 6. All right, so I just did a little bit of algebra, juggling it around a little bit. And now there's one thing left to do to get the y all alone. We divide everything by 2. And we're left with y equals 2x minus 3. So now we're set up. Now we're in slope-intercept form. We know the slope of this line is 2. Be really careful. It's not 2x. It's just 2. So if the slope of this line is 2, we can also write that as 2 over 1, if that helps you see it. So a perpendicular slope would be, we flip it upside down, so we take the reciprocal, and we change the sign. So since this is already positive, we're going to change the slope to negative. Okay? So there's our perpendicular slope of that line. All right, so you have 3 questions very similar to that on your online homework check. Do your best with them. If you have any questions, come see me after school, and I will see you next time in class.